Hello everyone, my name is Jahnavi and today I will talk about how durability of knee implant can be improved by enhancement of the mechanical properties of ultra-high molecular weight polyethylene using graphene and hydroxyapatite. Then we'll further discuss about the evolution of mechanical properties by tensile, friction and wear, hardness and creep resistance testing. Here is the roadmap of the presentation, which includes the motivation and current state of art, strategy, testing, and the conclusion. So now first look at the motivation and current state of art. So to get started, let's answer the question, what are the causes of total knee replacement revision surgeries and why it is important to improve the durability of knee implant? So according to the American Joint Replacement Registry, more than 75,000 revision surgeries were performed in the USA between 2012 to 2019, and it is expected to grow by 174% by 2030. As we can see in this pie chart, polyethylene wear is one of the major cause of the TKR revision surgeries, which accounts approximately 48% of the TKR revision surgeries. So there are other factors too, such as aseptic loosening, fracture, infection. So revision surgery is stressful for the older people due to their slow recovery rate, which leads to the poor quality of life and other health concerns. So now we'll look at the strategy to improve the durability of knee implant. Ultra-high molecular weight polyethylene is commonly used biomaterial as bearing surface in the total joint replacement as we can see here. It has high strength and high biocompatibility. However, it has low young modulus and easily creeping tendency. So different attempts have been made to improve the mechanical properties, but each technique has its own limitation. So according to the recent studies, enhancement of the mechanical properties can be achieved by addition of the hydroxyapatite in the polymer. So there is one another study showed that the graphene has the excellent mechanical properties which can be used to improve the wear resistance. So the novel approach will increase the durability of knee implant, which ultimately restore the health and will impact the millions of lives of the patient is major motivation behind this proposal. So now we'll look at the how graphene and hydroxyapatite reinforced ultra high molecular weight polyethylene will be fabricated. So this composite will be prepared by the process called the octa screw extrusion. This method offers the excellent mixing than the single or twin screw extruder due to the high number of the kneading screw. So the 1.08 percentage powder of the graphene and the ultra high molecular weight polyethylene with the average molecular weight of the 3.2 into 10 raised to 6 gram per mole will be mixed dry for the 10 minutes to improve the dispersion. After that, mixed powder will be placed in the octa screw extruder to produce the strips of the graphene and ultra high molecular weight polyethylene composite. The strips of the hydroxyapatite ultra high molecular weight polyethylene composite will be produced using the same method. The powder of nano hydroxyapatite with the volume fraction of 0.5 and ultra high molecular weight polyethylene with the average molecular weight of the 6 into 10 raised to 6 gram per mole will be compounded using the octa screw extruder. Rotation speed will be set at the 420 rpm and the preparation time will be around 180 seconds. So now we'll move on to the testing of the mechanical properties of the composites, which includes the tensile and hardness testing, friction and wear testing, and the creep resistance testing. So the first aim of my proposal is to conduct the tensile and hardness test on these two composites, and the result will be compared with each other and with the pure ultra high molecular weight polyethylene. So the tensile test for the measurement of the yield strength, young modulus, and the elongation at the break will be conducted using the universal testing machine with the 5 kN load cell. Test will be conducted 3 times and the mean values will be reported and compared with each other and with the pure ultra high molecular weight polyethylene. So for the hardness testing, nano indenter will be used as shown in this figure. So the typical loading and unloading sequence will be used and the unloading part of the load displacement curve will be analyzed and compared. The second aim of my proposal is the friction and the wear testing, which will be carried out using the Bruker UMT3 tribometer, and pin on disc configuration will be used. So the rotation speed will be 100 RPM and the time will be the 15 minutes. Then the Bruker will be used to measure the wear track depth, and the wear rate will be determined from the measured wear depth. So my final aim and the third aim will be the creep resistance testing of the two composite. It will be measured by the process of the ball indentation. So the constant load of the 50 Newton will be applied for 2000 seconds, and the indentation depth will be measured when the load will increase to the 50 Newton. So in conclusion, it is expected that the graphene and hydroxyapatite reinforced ultra-high molecular weight polyethylene will have the enhanced mechanical properties than the pure ultra-high molecular weight polyethylene. It is also assumed that the yield strength, stiffness, and the wear resistance of the composites will be superior to the pure ultra-high molecular weight polyethylene, which ultimately increase the durability of implant. So finally, the new approach can impact the lives of patients on the order of the millions. So these are the references which I have used, and thank you so much, and I will be happy to take any question on the canvas.